Well, concurrent is not parallel because they're two different words, right? So not a rocket science. So my name is Joseph Fernandes, senior software engineer. I work on GlusterFS data tiering. Apart from that, my interests are in deduplication as well as archival, so data archival. Well, what's the agenda? So first of all, we'll define what you mean by concurrency, what is being concurrent, what do you mean by parallelism. Niels, I hope you're not judging me, right? Okay, great. Okay. So concurrency with parallelism, okay. Just concurrent, not parallel. Well, we'll go into them. So advantages, disadvantages, pitfalls, okay. And different programming languages, these are system programming languages. I've not taken Python or any other interpreted languages here, which have their support. Okay, these are system programming languages, which support concurrency and parallelism. Okay, what do you mean by concurrency? Concurrency means dealing with a lot of things at a time. Okay, that we do every day, right? When you multitask every day on everything. So let's start with a real life example. Okay, I go to a restaurant, might be a Urpi Darshini, and I think, let me have a masala dosa and a coffee. Okay, now look at this behavior. What I do first is I go to the counter, I buy a coupon for a masala dosa, I buy a coupon for a coffee, right? And then I go to the masala dosa counter and I say, "Anna, one masala dosa." I give the coupon there. Okay, it's a blocking call for me because I'm not royalty, so he's not going to give me the masala dosa immediately. So I need to wait. So what I do, I say, okay, fine. Let me context switch and go to the coffee counter and give my coffee coupon, and I say, "Anna, one coffee." Okay, yeah. So and he say, "Yeah, fine. 1 minute." So what I do is, okay, this is boring life. Let me go back to the chair, read some newspaper, okay. And suddenly, the masala dosa man actually calls me and said, "Your masala dosa is ready." So I context switch. I go back, pick up my masala dosa and come back and start eating. And when I'm eating, this miserable coffee guy calls me saying, "Your coffee is ready, man. Take it off." So I'll go. I pick the coffee. Okay, my masala dosa is still on the table, and I come back, and of course I have to eat and drink, okay, which can be simultaneous if I'm really hungry, or yeah, I'll do it sequentially, and I leave. Now, what is the point here? Why did I bring up this example? Is I am a single person. I concurrently did how many tasks? 1, 2, 3. 3 of them by context switching, right? So I constantly context switched, okay. Being a single, I had 3 tasks to be done, okay, and I context switched, did them. Since I was blocked on something, I went to another one, did something there, went to another one because I got blocked there, okay, and so on. Basically what I did, I divided the problem into smaller tasks and solved them little by little, okay, not in a parallel mode, concurrently, single person, okay, with a single CPU, right? I just have a brain, so I don't have 2. So I just did one thing at a time, but concurrently by context switching. What is parallelism? Parallelism is doing a lot of things at once. Now, okay, let's think that I am an alien, okay, and I have some really good capabilities or superpowers. Okay, I come here, I say, "Hey, I want masala dosa and a coffee." I clone myself, right? I clone myself. So I get 2 Josephs. Great, good for the world. So yeah, I say, "You 2 Josephs, go and wait for the thing. Okay, take your coffee coupon, do whatever, and I might be waiting or doing something else." Okay, and they come back to me saying that, "Hey, this is your stuff," and they say, "No coffee and no masala dosa for you, join." I go back, I eat and leave. This is the usual way we write multi-threaded code, right guys? The first thing when we write a web server is, whenever a request comes, spawn a thread, right? Web servers in Java, how many of you have implemented? No Java guys? Python? Are there? Right? So this is the first thing that we do, okay? Now, no offense to that. It's one way of solving the problem, because you can. Now, what I did was, I have multiple cores, basically multiple, if, again, that depends upon your machine, whether it has multiple cores. I divided the problem into completely parallel tasks and start solving them, right? Now, let's look at this model. Let's look at complete design of Udpi Darshini, how Udpi Darshini is designed. So this is the concurrent user, that is me, hopping around counters here and there, context switching, okay? And behind the scene, when you give your coupon to the masala dosa person, actually he's not the masala dosa person, he's the person who actually takes your coupon. That's all his job. He will take a coupon for Uppittu also, or something else, anything, okay? Now what he does is, he takes the coupon, he's not bothered, he just goes and places it on a food queue, food ordering queue, comes back. He's not blocked, okay? And his job is to move these tickets, dispatch this ticket, and dispatch the food that comes out of the queue, right? Now let us go to the dosa master, who actually is busy with dosas, okay? He gets a masala dosa, 2 set dosas, 1 onion uttappa, fine? Okay, guys, carefully listen how concurrently he works, okay? He puts some masala dosa batter, then he puts some set dosa batter, then he goes to the onion uttappa. By then he sees that the masala dosa batter is getting cooked. He puts oil on it, and so on. I'm not going in the recipe now. But the point being, he is being concurrent, right? He's context switching continuously. Yeah, might be he's getting tired, but yeah, he's context switching. And finally, he places those plates onto the food that is ready. And then you have the dispatcher thread, or the person here, which is dispatching the food. And he calls me, I'm reading the newspaper, context switch, go back, pick and come. This is, all of them, all the actors here, okay, who are working, are concurrent in nature, right? Why not our code? This is the complex system. This is a crazy Udpi Darshini with a lot of people coming, and yeah, the owner one finally day, he thought like, oh yeah, I want 2 dispatcher threads, I want 2 dosa masters, okay? Now just let's look at the dispatcher threads, or the order receivers. So suppose that a customer, Vishwas, he is the customer, he actually gives a coupon to me, I'm the dispatcher, so he says 1 masala dosa, so I go and place it. Okay, by then Manju Prasad comes in and he gives me a coupon saying that a set dosa. But by the moment I go back and place this order, the masala dosa is ready. Does that mean that I have to give the masala dosa to Vishwas? Vishwas, right? You ordered it. So the other guy will pick it up and give it, right? So we, the dispatcher threads here, are context switching. Okay, we are not stick to a context, right? The same thing, let's look at the dosa masters behind. How do they work? The same thing. So instead of one guy doing all that, he says that the dosa is going bad, might be you should put some oil or whatever it is, and yeah, he goes and does it, okay? You can consider these people as thread pools which work concurrently, right? And this whole design is concurrency with parallelism. Well, the whole purpose of my talk today is not to show you some code or show you how it is done in C or C++, run some code and show you. The point here is concept, making us aware that by writing concurrent code, a concurrent and a parallel code, you can write a far performant, optimal system. This one. Now, let us think of an I/O system. Everyone deals with an I/O system every day. REST APIs, right? Clouds, Facebook updates going up, file system saves, which you write to the disk, so many things. So you have your application, okay? To have things very simple, I will just use non-concurrent threads on the user side, okay? And I have an API, so everyone, for file system, it would be read, write, and open, read, write, close, and so many other APIs, okay? Within my IO system, I have concurrent threads that context switch, okay? So their job is to actually dispatch the message to the IO device interface. Now, in the IO device interface, below there might be concurrent threads which are working on it, and they come back saying that, hey, your job is done. Done? Okay, let me go and give it to him. Okay, so this dispatcher threads, you can see, they constantly, they concurrently and parallelly work. Okay, so that's what we do in clusterFS also. By, yeah, we have a way of doing it. Now, how do you achieve it? Is now when the user thread comes in, what he does is it's a blocking call for him, right? So he has to wait for something to come back. So he says that, hey, listen, when that thing comes up, you just wake me up. This guy is not concurrent. That's the reason I've kept it non-concurrent. Okay. By doing so, this thread goes to a sleep and is only woken when the result is back. By doing so, what you have done is not having the thread spinning on something and humming your CPU just for a block, right? So, and where does he put that? He puts it in the memory. Somewhere the context can be, somewhere where the dispatcher threads can pick up. Now let us look at the dispatcher thread or the concurrent IO threads, okay? So his job is to look into this queue of picking up the different contexts that are put there, and he says that, hey, this has to go to the IO system and this has to be given back to him. Now this single thread, you can see it is jumping around so many contexts. It is running somebody else's code, right? It is not, the body of that thread is not defined. It actually goes, it's a defined, but yeah, it's more, defined by the context that has come in. Right now it may be catering to open system call, or the next time it might be bringing acknowledgement to the read system call, and so on, ping-ponging, okay? And if there is nothing, I mean, no IOs are happening, you'll just go and sleep, okay? Now, what if, there's an interesting problem. The problem is, so all of you might have Unix pipes. Interprocess communication, how many people know what are the different interprocess communications? Yeah, please go ahead. Give him a mic. There, the guy with the t-shirt. Not you, sir. I know you know the answer. Your good name?
Karthik. We have message passing and stuff like that.
Stuff like that.
Message passing, sharing memory and things like that.
Okay, have you heard of something called as process semaphores?
Yeah, they allow you to block and
have you heard of pipes?
Yeah.
Have you heard of shared memory?
Yeah.
Sockets?
Yeah.
Right? These are all interprocess communications. Okay. Now, to have interprocess communication or anything of this sort, you should have two instances of something running, right? Either two processes or maybe two threads running and doing stuff. Now the problem here is there is a producer and a consumer, okay? And your project lead, who is very adamant, he says, boss, only one thread. I said, no, sir, it will take two threads. No, boss, only one thread. I want only one thread. I can't, anyways, the performance team is shouting that there are already so many threads in my system. I want one thread. Crazy guy, but yeah, you have to comply, sorry, and apply. So what do? Your consumer, usual thing is, somebody writes to the pipe, usual pipe, right? You write to the, it's like this, you write to the pipe and somebody takes out. Sockets, you write, you read, right? But the problem here is you can't run two instances of something. How do you solve the problem? So this is what the problem is, right? When producer A creates a character A, the consumer consumes it and does something with it, and then he comes back, okay? He produces B, okay? It's a single thread. There are no multi-threads here, okay? And it goes to B, and when he gets end of file, he said, okay, fine, done. Answer is coroutines. Now, what are coroutines? Have you heard of coroutines? Anyone of you? No? None? Okay, fine. That means I can say anything. Okay, coroutines are functions, basically subroutines, where you can break in middle of somewhere in the body of the function, leave the function, okay, context switch to another function, execute that little bit there, come back to this, execute a little bit here, go back to another function, execute that little bit, and do that kind of stuff. How is it done? You need to save the context somewhere, right? You need to save the stack. It needs to save where your last PC was, right? Your program counter was. You need to save all that. Well, there are programming languages that support these. Okay, I'm not going in very detail of code, okay, but I would suggest you guys, to whatever pointers I give here, go back and explore on this. Okay, here now, assume I want to implement the same IO system which I had here. Okay, I say that, yeah, I want to implement it from the scratch. Okay, and what are the benefits I would get, or might be I want to use them. First of all, of course, you're using threads very responsibly. Okay, you're going to get a performance boost. Your program is going to be more responsive. You're approaching to a problem with a real life approach, okay, rather than just spawning a thread every time. Your code is modular and hence less duplication. And then, of course, you're efficiently using your multi-cores. Well, be aware of these. You are using a place where you're putting the context, right? So you're saving something and then coming out of it and then going in. Okay, don't you think you would require memory? Okay, first thing. Second thing is algorithms. You would require algorithms or data structures to implement all this, right? You cannot use linked list. Come on, guys, don't give me that. A linked list, no, not a queue. Okay, I'm just saying. Okay, a tree. Then I'll say, oh, it's a balanced tree, not a balanced tree. Then what? Then what? Okay. Next one is concurrency and synchronization bugs. Okay, and debugging them is another nightmare. Okay. Next one is you may finally be the guy who actually did it. Yes, I did it. Fine. Performance. I mean, if you had chosen a queue and yeah, now about the locks. That same performance thing, your threads might be running very smoothly, switching context beautifully, everything fine, but they're blocked on locks, mutex locks, or any locks you use. Okay, and suppose that you wrote code, okay, which is there, which is supported in, and the operating system which is there, which actually supports that. What about portability of code? All these things actually brings an analogy to mind. If suppose that you want to build a car, okay, and you are an expert in engines, that's your expertise. You know how many cylinders are going to produce, how many horsepower, with what fuel, with what tunable, blah, 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 and so on, right? But are you going to reinvent the wheel? Are you going to reinvent the chassis? Are you going to reinvent the body, the glass? No, right? You give it to somebody else. Exactly, right? You know, of course, you cannot just give it to anybody, right? Panchar angadi wala, you cannot give a tire, right? So I'm just giving an example. I mean, there is some reputation and some trust that you need to have, okay? Now, let's go to, keeping that thought in mind, let us go to the different programming languages that we have, which supports this. So you have pthreads, you have mutex locks, your condition variables. I'm not going in detail how you implement it, okay, because that would be another talk, okay. So you have atomic variables that you can use, and then you have, of course, you can write coroutines using set jump and all these functions with jump. Definitely you can do it. These are non-local jumps. I mean, a non-local go-to state. When you use a go-to, it's actually local. But you can jump context switch by using a variable, okay? Or let's go advanced, C++, right? C++ anyway supports all this, no problem. But they also have something called as coroutines. Check out, guys, okay? There are some good stuff there, okay? Boost libraries, right now it's in Boost library. I think so C++ 17 would, they are planning to standardize it, okay? Now, the point here is, think of this. Are you trying to just be concurrent? Are you trying to be just parallel? Or would you like both, concurrent and parallel? Okay? If you want both, the complexities increase, and then you have to maintain. See, writing code is good. For fun, good. You write nice C code, you do all this, fun, or in C++ also. But finally, when you have to maintain it, when you're writing it for an enterprise software, because at the end, your customer is using it, and suddenly your system goes, it doesn't move, because your code is all locked everywhere, entangled, and it falls. You don't want that to happen, and you have to maintain that. And finally, you will come to know, just in case of all the bad things I told here, is that because of whatever your sloppy design is or whatever it is, okay, you had reinvented the wheel. You did reinvent the wheel where you could use standard libraries which are out there, okay? And now, the beloved, sorry, not thank you, and not yet. Well, this is the new programming language. Atin Mukherjee is going to talk about it, okay? It has something called as coroutines and channels, okay, which gives you both concurrency and parallelism. Point is, it is totally abstracted from you. You don't even know what is happening behind, but it gives you the performance. I have examples here people who wrote Goof Talk. They are going to give a talk tomorrow. You should go to GitHub repository. It is called as Goof Talk, okay? It is completely written, it's a chat server application written in Go, okay? Just go and have a look at, they wrote unknowingly, if I'm not mistaken, I'm not explained you all this, right, guys? Okay, they have written a concurrent and parallel code because the system is providing all this out of the box. Okay, that's it. Thank you.
I don't know which slide you are referring at, but in one of your example, right, you are talking about your boss was saying that you have to be strict with a single thread,
that's
and you cannot,
thing, yeah.
go to multi-thread, and then after that you brought in concurrency, right? The coroutines and channels.
Yeah, no, I was just explaining what is concurrency as pure, without parallelism. You can have pure concurrency. You can write programs which don't use multi-threaded. It is the same main thread, which can still do this stuff.
Yeah, so probably my slide covers that. Although technically coroutines, we say that they are not multi-threaded, but they work like multi-threaded.
Well, that is the point. So a coroutine is abstracted. Internally, you never know how big the thread pool is. Okay, internally, okay, I'll give you a very simple example here, guys. Okay, the example of the same function, right? Producer and consumer. Okay, there was only one thread that was replying back, correct? Jumping around here and there, and you know that because you wrote the code. Okay, but if you're using a coroutine, and I'm pretty sure for that scenario you're going to use a Go channel.
Yes, absolutely.
Yes, you're going to use a Go channel. When you're blocked on that situation, okay, your control flow, your thread which was there might go and do something else in your system, in your process, which without your knowledge, because it has been optimized in that way. Now, what is the optimization I'm talking here? Okay, let me talk about this. So recently, I don't remember the name of, I think he was a Russian, yeah. So there was CPP Con, a conference, C++ conference, and they were talking about Go routines, okay? And he explains that how, I mean, you implement something like this, you want to implement, okay? He writes code, and he says that, oh, I'm not getting the performance. Let me make it more better, but still it cannot beat the coroutines. Reason being, he gave 3-4 points there. Okay, the 3-4 points are, first of all, is the memory management. When you do memory management on user space, even though you have a mempool, as we do in Gluster, I think we use a mempool, right?
Yes, we do.
Yeah. So you have a overhead of bookkeeping. You have to remember, oh, this memory here, there, fine. Okay, that overhead is removed by coroutines. Of course, they might be having something in the kernel. I don't know. I really don't know about it. Okay, which is doing all these optimizations, which he claimed in that talk. So I would recommend all of you guys to think of multi-threaded programming in a different way, not just spawning threads. And trust me, when I came out of college, okay, when I wrote my first web server, and that's the reason I asked. I think in MCA, you people, I'm an MCA grad, so in MCA there is, in Java, it ends up with a web program or some kind of REST program or something. So where you spawn threads. You spawn threads bindas. But that is the problem. Any more questions? I have more time.
Hello, Joseph.
Yeah.
My question is regarding the DOSA center.
Yes, sir.
Okay. Suppose, okay. So if there are 10 users or 20 users, we can manage easily using monthly thread and concurrency.
Yes.
What if there are 1 million users at the same time? How we will manage to give dosas to 1 million people at a time?
Well, you go in the queue. That is the point. Not all of, that is your limitation of your IO system. You cannot hit the system. You cannot hit the system with definitely. For example, any IO systems you see, okay, humane way, forget about humans working here. I'm just talking about there are GlusterFS, our own IO system that we have built. Okay, we get so many FOPs that come and hit us. Okay, how would you manage it? You know how many threads we have internally? At the max, it grows to 16, right, Atin? 16 IO threads with the SyncOp framework. Only 16. You may say, only 16 threads? How could you do it? Because they are not blocked. They're just dancing around here and there. They're saying, hey, this is your message, this is your message. Dispatching threads, they're called dispatch threads. Okay? But the 1 million threads which the user created, they are blocked. That is not our headache, because he created 1 million. Of course, there is a performance degradation there. You are running what, 1 million threads in a system in one laptop, and that is where, okay, again, there is a solution for this, and that is where distributed system comes into play, where you actually balance your load off, where you don't have just one machine, okay. You just have multiple machines where the distribution happens. It says that is what the distribution Karthik was talking about. File 1, go to that. File 2, go to this. Right? Yes.
Yeah, so I think it's a brilliant question what he has asked.
Yes, of course, of course.
I actually have an experience. I have an experience related to this particular problem. I had a fortune to work for a stock exchange. I believe you guys are aware of National Stock Exchange, and there we talk about billions. Forget about millions, we talk about billions. Now if you refer to this diagram, right, when we talk about any subscriber publisher model, so the rate at which your subscriber subscribes the number of messages may differ at the rate of what your publisher publishes, right? So there could be a discrepancy. And that's where a concept comes as, they call it as back pressure. Like at the rate at which I can process the number of messages, If it doesn't match with the number of incoming messages, there will be a slowdown in the subscriber module itself. So you have to be very careful about designing the queue depth, which is really crucial here. So if your queue cannot handle that many number of message or that many number of buffers, you can really be in a dangerous position here. Yeah.
Again, with the point of queue, you need to take a lock when you read it and when you have to update it. So be aware when the word queue is more of logical than the implementation itself. Use the best data structure which actually gives you less blocking, okay, which blocks the thread less. Now, what data structure you want to use, yeah, that's another topic for another day. Okay, that's it. Well, I'll take, since I have some time now. Oh, you have a question, okay.
Convert into concurrent ones. Can I do that?
What language? That is again, whether your language supports it. Are you using C? Are you, if you want to do it, concurrency there. Again, what is the effort? Whatever, okay. Okay, by the way, okay, let me not discredit of other languages. There are other languages. Python actually gives you coroutines. There is Rust, which actually helps you with concurrent and parallel models. Okay, Python not being a system language, I have not mentioned it here because, of course, there is overhead of interpreter. Okay, but of course, Rust is definitely a language people should look at. Okay, so again, to your question, it depends upon what language you use. Okay, whether that support is there or not. If you're using Go, okay, that support comes in. If you're using Rust, that support comes in inbuilt. If you're using C++, you might want to use coroutines. Okay, so it depends upon how much of things you want to do.
Even the vice versa is possible. Like
Pardon me?
If there are concurrent threads,
yeah,
you can change into parallel. Even that is also possible.
Yeah, that is possible. Yes.
So both the ways it is possible.
Yeah, that's.
Joseph.
Hello.
If you don't mind, if I can add to that.
Please go ahead.
So basically, when you're as Joseph mentioned, that this is basically a concept, how you want to handle something, a process, a routine, right? How you want to handle it. You can do it in a parallel way, you can do it in a concurrent way. So if you can break down your problem into a parallel solution or a concurrent solution, it doesn't matter which language you use, so to say. What Joseph tried to mention is that some languages have built-in support or already developed libraries to handle these situations. Some language might not have, so you might have more problem developing in those languages. Basically, that's it. Otherwise, it's just a concept.
Well, this is not a discouragement of not using those languages. C is one of the fantastic languages that people use. Okay, it's performant, but again, C. My point being here, it's not that C doesn't have those libraries. There are, if you go to GitHub and search, you will find libraries. But again, these are, is it reliable? Do you want to use something which is like freshly baked? Or do you want to use where people are thinking of standardizations? Or something which people are really marketing it, saying that this is our feature. Go is concurrent and parallel, or might be Rust also. Okay, so, well.
Hello, sir, I have one question.
Where, who?
Sir, here.
Oh, yeah.
When we say the word distributed,
Yes.
it is just like processes or the threads executing in different machines.
Yes.
Or when we say with respect to the parallelism,
Yes.
The threads executing in the multiple cores. So what is the exact difference?
See, the difference here is when I spoke about the threads, okay, it is one IO system, it is one process I'm talking about. Okay, so you are limited to within your process space. Okay, now when you distribute things, when you're doing load balancing stuff, you go parallel, yes, but internally they are concurrent and parallel by themselves, all the threads. Okay, you don't want, for example, GlusterFS bricks we have, which are like server components. We don't want all the load to go to one brick. That is not how GlusterFS has to be used, or might be Ceph. They have their own background, so I don't know the name. But yeah, they wouldn't be happy to send it to their one single server process, okay, or any other distributed system. If you compare it with the physical file systems which are there, that's a different ball game. Okay, but there again, it depends upon, see, all these distributed file systems, they themselves have concurrent and parallel systems, okay, but they also rely on the kernel to provide that to them. Okay, the file system which we use like XFS or Extend4 or any file system you have, okay, they themselves, but there is a limitation. This again, this is not a magic wand which solves all the problems, but makes life better. Okay.
Yeah, no, that is okay. For example, another thing we say, a concept of creating a single system image, and we have the distributed systems. Means we don't know while we study about the distributed operating system and all, we talk about the distributed system where we create a single system image, means using the middleware, and underlying systems which is processing our task is unknown to the user. So,
well, when you bring in virtualization, you're talking about virtualization.
Yeah.
The question here is, when you bring virtualization, is performance not a trade-off? You already said that you are trying to do a lot of stuff by giving abstractions over abstractions. Don't you think you are already saying that there is a performance impact there? What you can control is that in such kind of systems, okay, you can have quality of service which actually controls, not one guy hogs everything up and goes, and rest of them are suffering. But of course there are limitations. The IO systems are limited. Very good example I can give you with our whole IO system and the system stack we have is recently one of my friend was looking into the persistent memory, not flash, but actually the memory which is persistent. Ours is a volatile memory, that is a non-volatile memory. Everything is fine, but the whole storage stack itself is built in such way that you cannot leverage the performance of that non-volatile memory. So yeah, again, these are not new concepts. Whatever I spoke here, these are concepts which they are called as cooperative multi-threading. Yeah, and there are actually papers written on this, how it is done.
Okay.
Okay, cool.
Thank you.